So first of all, sulfur is removed from the crude oil, and then it's heated as it goes into the fractionating column, which is used to split the crude oil into its constituent components, mostly hydrocarbons. At the bottom is the residue, where there are chains with 25 or more carbons, and that's where the highest temperature is. And using the different boiling points, you'll split apart the various components of the crude oil into gas oil, kerosene, gasoline, and finally refinery gas. Now you have to know about the thermal gradient as well. So it's hot at the bottom and cooler at the top. So what are the uses for these various fractions of crude oil? Well, let's start with the lightest fraction that comes out at the top. That's used for cooking gas and feedstock. Feedstock is a reactant used for other chemical processes. Slightly heavier is the gasoline and naphtha with 5 to 10 carbons in a chain, used for petrol. Jet fuel and helicopter fuel is the next fraction, which is kerosene. It's also used for domestic heating. I've also put the boiling points there as well. Now kerosene, you can actually make it into something more valuable if you cut it in half, and that's called cracking. That's the subject of the next video. Gas oil is even more thick and dense, and it's used for diesel and industrial heating. Quite a high boiling point. And finally we had the residue, which has the longest carbon chains, and that's used for oils, bitumen, which is the pavement I'm jumping up and down on, and the fuel for power stations. This has a very high boiling point, at least 350 degrees centigrade. Now I've lined up all these oil barrels, and I was going to talk about fractional distillation while they blew up in a circle. Okay, so this is only a very trivial coverage of it. It's much more in depth, but this seems to be as much as the IB wants you to know. If you're doing the A-levels, you've got to have a whole lot more information, including the famous bubble caps. And we're done.